All right, now that you know about chemical symbols, let's talk a little bit about chemical equations and how they work. So a chemical equation is designed to show you all of the substances that are involved in a chemical reaction. So chemical reactions you learned earlier in our unit are all about when elements combine with one another to make new substances. Well, we can represent those chemical reactions in a chemical equation, and doing so helps people to understand all of the elements that are involved. And you can see an example of a chemical equation right here at the bottom of the screen. And there are two sides to the equation, right? And right in the middle there's an arrow. And that arrow is telling you, what it's saying to you, is that when these substances are combined or broken apart, it will yield or make these substances over here. Guys, see how that works? So the arrow represents yields or makes. Now, on the left-hand side of the equation are substances that we call the reactants. And the reactants are the substances inside of a chemical equation that are broken apart. Okay, so we call those reactants. Now, on the right-hand side of the chemical equation, we have what are called products. And those are the substances that are formed as a result of the chemical equation. And you should remember that without too much trouble, because remember that arrow means yields or makes. So these are, in my thinking, I like to consider these the ingredients, and this is the final product. Okay, we call these reactants. They're the substances that are going to be broken apart and rearranged in order to create your final product. Okay, reactants, products, and that arrow represents yields. Okay, now there's something really cool about chemical reactions that I love. And the thing that I loved is that chemical reactions are always balanced. And what that means is that you don't really gain or lose atoms of anything in a chemical reaction. Instead, all that happens is atoms are rearranged into new substances during a chemical reaction. We call that the law of conservation of matter. Stated simply, it's matter is never created or destroyed in a chemical reaction. It just changes forms. And you can find proof of that in a chemical reaction or in a chemical equation. Here's an example of that. I'm showing you a chemical reaction right here. And if we look at the reactants carefully, we'll find out that there is 1 atom of carbon, 4 atoms of hydrogen, and 4 atoms of oxygen. Where do we find those things? Well, we've got a subscript here, right, which is telling us that we have 4 hydrogens over here. We don't have a subscript after this C. That means we only have 1 atom of carbon over here. So in this part of the reactants, we have 1 atom of carbon, 4 atoms of hydrogen. And then on this side, we can see a subscript telling us that we have 2 oxygens. But we also have a superscript telling us that we have 2 of these. And what that really means is that we've got 4 total oxygens. Well, if you add all of those up, you get 1 carbon, 4 hydrogens, and 4 oxygens. Now, if you go to the other side of the equation, you can see that our substances have rearranged, haven't they? We no longer have 2 O2s. We no longer have a CH4. Instead, we've got a CO2 and we've got a couple of water molecules. Okay, so you can see that the atoms have rearranged themselves. But if you look at the formula and you go through and do the math, you'll notice that we've got 1 carbon, 4 hydrogens, and 4 oxygens over here on the product side as well. We call that a balanced chemical equation, and all chemical equations are balanced. What that tells us is that matter is never created or destroyed when you're looking at a chemical reaction. Instead, it rearranges itself into a new substance. And to prove that, all you've got to do is add up the number of individual atoms that you have on your reactant side and compare it to the number of individual atoms that you have on your product side. They should be equal to each other. If they're not, somewhere along the line, you've made a mistake. Now, some chemical reactions need to have what's called a catalyst. A catalyst is a substance that will speed up a chemical reaction. Now, catalysts always remain unchanged in the chemical reaction, so they don't become a part of the products when new products are made, and they're not destroyed by the chemical reaction. Instead, they're just a substance that helps to speed up the chemical reaction. In the presence of something, the chemical reaction will get faster. And we always write the catalyst above or below the arrow in a chemical formula. Now, that may seem really confusing to you, but I'll show you one that I'm sure that you'll understand. Here's the chemical formula for photosynthesis. So you know that photosynthesis is the process of taking carbons and water molecules and combining them together in order to create energy for human beings, right? Or in order to create food for human beings. Okay? Well, and I guess I said that wrong. It's not really creating food for human beings, but instead, it's the process where plants create food for themselves. Let's be sure that I'm clear about that to begin with. Now, if I asked you what was necessary in order to make photosynthesis happen, you would tell me that plants need chlorophyll because that's where the photosynthesis occurs, and they also need sunlight because sunlight's a part of the chemical equation. Well, those are both catalysts for photosynthesis. And you can see in the chemical formula, we write those catalysts above or below the arrow. Now, these catalysts will speed up the reaction. They're essential for photosynthesis to occur. But sunlight and chlorophyll are not destroyed by, and they don't become a part of the products. Okay, so they're there representing the fact that they're essential to the chemical reaction, but they're not destroyed by, and they don't become a part of the products. Okay, does that make sense to you? So these are called catalysts. All right? Now, I do want you to know one final thing. Chemical reactions can happen at different rates. Some of them happen very slowly, some of them happen very fast. And don't forget, when we talk about a chemical reaction, we're talking about atoms and elements rearranging to make new products. Now, sometimes we can intentionally change the rate of a chemical reaction. And we can do that by either increasing the concentration of the reactants. So those substances that are on the left-hand side, if we can increase their concentration, we might be able to speed up a chemical reaction. Sometimes if we change temperatures by heating things up, we can change a chemical reaction. Sometimes if we have a larger surface area, we can speed up a chemical reaction. And then last but not least, obviously, some chemical reactions are sped up by the use of a catalyst. Now, not all chemical reactions can be sped up. We can't change the rate of all chemical reactions, but in some cases we can control how fast or slow they happen intentionally. And that would have value to us as humans as we're trying to manipulate chemical reactions for our own good.